All right, let's go ahead and practice writing some transformed functions based on a verbal description. So this first one, you may want to pause the video and go ahead and write this information down so that you can follow along a little better, and then come back and watch how we write the new function. Okay, so we want g of x to be a vertical stretch by a factor of 2. So remember, a vertical stretch is going to happen outside in the front. And then we also want to reflect in the x-axis. And then after that, we want to move 3 units down. And we are starting with our parent function, f of x is equal to x squared. So I'm going to rewrite the parent function down here just for reference. F of x is equal to x squared. The first thing that I want to do to this, and I'm going to call it, h of x. H of x is going to be a vertical stretch by 2. So that means I'm going to put a 2 out in front of my x squared. But I also have a reflection in the x-axis, which kind of goes along with that 2. It just puts a negative sign on it. So h of x, after I've done those first 2 transformations, is negative 2x squared. Then I need to transform it further to g of x. My final transformation says that I need to move 3 units down. Remember that moving up or down just occurs at the tail end after everything else, and down is a negative. So my final answer is g of x is equal to negative 2x squared minus 3. All right, this next one says that g of x is going to be a translation 3 units right and 2 units up, and then followed by a reflection in the y-axis. So a reflection in the y-axis, remember, is actually going to happen inside of parentheses right there in front of x. We're also not starting with the parent function this time. We are starting with f of x is equal to x squared minus 5x. That's going to complicate things a little bit, but we can handle it. So again, just for reference, I'm going to write what f of x is. F of x is equal to x squared minus 5x. I'm going to call my next function h of x. And h of x is doing 2 things. We're going to translate 3 units right, and we're going to translate 2 units up. So remember that horizontal translations occur inside with x, and they cause us to go the opposite direction. This means that if I want to move to the right, I need to replace x everywhere that I see it with x minus 3. Remember, going to the right is a negative sign. So the first time that I see x is it says x squared, but I'm going to replace that with x minus 3 squared. And then I see a minus 5x, so I'm going to say minus 5, and again, x minus 3. Finally, I need to move 2 units up, and remember that that just gets tacked onto the end, so I'm going to say plus 2. All right, you notice that we have an x minus 3 squared. That does not mean take x and square it and take negative 3 and square it. There's more to it than that. Remember, it's the entire quantity squared. So let's expand this to make it a little easier to look at. This is the same thing as x minus 3 times x minus 3. And so I'm going to write that as my next line in order to be able to see what I'm doing a little better. And so just to kind of remind you, anytime that we have something that looks like this, we need to distribute both of the terms in the first parentheses to both of the terms in the second parentheses. Let's see what that does for us. X times x is going to give me x squared. X times negative 3 is a negative 3x. A negative 3 times x, moving on to our second one, is also a negative 3x. And then finally a plus 9. All right, I've got some more distribution to do here. I need to distribute the negative 5 to the x and the negative 3. So doing that, I'm going to get a minus 5x plus 15. And then don't forget that plus 2 that we tacked onto the end. Woo, this could use a little cleaning up. So I'm going to identify anything that is a like term. I don't see anything to go with the x squared, So that is just going to come down by itself. But I see several things with an x. I see a negative 3x, a negative 3x, and a negative 5x. Combining all those together, I get a minus 11x. And then finally, let's combine constants. I see a positive 9 and a positive 15 and a positive 2. So that's going to give me plus 26. So finally, we have h of x. All right, the last thing that we need to do is a reflection in the y-axis. Reflections in the y-axis, that's going to be a negative sign inside with x. So everywhere that I see x, I'm going to replace it with a minus x. So minus x squared minus 11 times minus x plus 26. I can simplify this a little bit and get rid of the parentheses, giving me a final answer. If I take negative x and square it, it's just a plain old x squared. Two negatives make a positive. Negative 11 times negative x gives me a positive 11x and then plus 26.